Hello to all participants and thank you for joining the third edition of our free online webinar Hoppy Topics. We would like to welcome you to today's presentation about hopping of low and alcohol-free beers. My name is Sandro and I'm the manager of technical support at Hopsteiner in Germany. I'm guessing you've all become familiar with webinars over the past few months, so I'd just like to say a very brief word about our setup. The webinar is scheduled for 1 hour in total, starting with a 40-minute presentation and followed by a Q&A session. During the webinar, both your microphone and the camera will remain off. You can ask questions or make comments at any time through the Q&A tab in the webinar menu. The questions are directed to me and I will pick them up at the end of the presentation. Our presenter today is Frank Pfeiffer, our technical director at Hopsteiner. Frank started his brewing career 35 years ago after receiving his degree as an engineer in brewing science and beverage technology. Prior to his career at Hopsteiner, he worked at the Bayerische Staatsbrauerei in Weihenstephan as director of the operations. In 2015, Frank joined the German Hopsteiner team as technical director. He provides technical support to many breweries and brewing groups across the globe. He supports R&D activities and new product developments and best usage of hops in the brewing process. Besides, he's also responsible for the processing and packaging plants and our technical advisor for the optimization of hop processing technologies. Frank, I'm sure during your time at various breweries, you've become an expert on the different ways to produce low and alcohol-free beers, and we are happy if you share your expertise with us now. See you later.
Yes, Sandro, thank you very much for your kind introduction, and good morning and good day, good afternoon to everybody around the globe. I'm here in Mainburg live on there, and yes, as you mentioned before, Sandro, topic today, I had the chance to create something like a non-alcoholic or alcohol-free wheat beer. It was in 1996 in Weihenstephan Brewery, and then we started with Helles, alcohol-free, and we also had some activities on the application of light beers, light wheat beer, for example. And so it helped a lot, and we were able to make some tests there together with the university, together with Professor Buck. I want to mention here today, he helped a lot to start with a very good product and a good, let me say, good product quality. But as you can imagine, the beers I mentioned are not very hop related, so it was very hard to bring something on the table with a good quality, good flavor, and a good drinkability. So that's, I think, for me, it was a starting point to think about how to make these beers a little bit more drinkable, a little bit more higher in quality, in taste stability, and so on, because that's all something that is not the same with the regular beers. That's something special here where we're talking about this morning. Okay, so my topic for today is hop products for low and non-alcoholic beers, and now let's see what are my ideas regarding these topics. At the beginning, I want to talk a little bit about the characterization and also the technologies that we have, that we know, to produce low alcoholic beers and also to produce non-alcoholic beers. And then I want to talk a little bit in general about hopping technologies for taste and quality improvement. That is more related to standard hop products. And then we go to some very special hop products that we recommend for usage in the brew house and also for application in the downstream area in the beer processing. So definition, what is light beer, what is alcohol-free beer? I put something together here on this first slide. We see there are a lot of different definitions and different kind of categorization that we find all over the globe. Here are some examples from Germany, Italy, that's in Europe, in the European Union, with different definitions. You can see, especially regarding the non-alcoholic beer, that is in Italy, it's below 1.2%, and in Germany is below 0.5% alcohol. That's something that's also common in a lot of other countries in Europe and also in the United States, for example. But let's also look on the light beer and on the light beer category, we see that this differs a lot. In Germany, we can talk about light beer and we can also talk about chunk beer. Normally, when you make a beer in between 7 and 11% Plato, you come to an alcohol content that is a little bit below 3%. And so you can meet both definitions, light beer and chunk beer. And go to other countries, reduced alcohol beer for Canada, for example, that is alcohol between 2.6 and 4%. So what they call light or lit beer in the United States of America, that is not really that light. That is an alcohol concentration of around 4.2%. And that's normally an average around 16% less alcohol than in the top brands of the breweries. So that's something that tops the alcohol concentration that we know here in Germany or in other countries in the European Union. Now we are going to the technologies that we know, that I know regarding the processing, starting with the category of the low alcoholic beers, of the light beers. And you can make a stop fermentation, but that makes no sense because that will lead in a lot of effort, in a lot of trouble, and also in the technology and to handle this process, that doesn't make sense. So it's not usable. Practicable is a dilution of high gravity beer or regular beer with water. It's the easiest way to produce a light beer or a low alcoholic beer, but the problem is when I add a lot of water to the beer, it tastes like that. And the mouthfeel will also not follow the expectation of the consumer. So the best option for me is still to brew light beer right up from the beginning with low gravity in the brew house, something in between 7 and 8 degrees Plato. That's comfortable for these beers with a good drinkability, and also the mouthfeel is okay. And yes, we have no wort-like character. We have a full fermented beer. We can play a little bit with the malts, with special malts that gives a little bit more mouthfeel, a little bit more character, and a little bit more body to these light products. And it's also an option that I tested. It's a mixture, a blend of 50% regular beer with a DeAlkalized beer, also in 50-50. And here we normally result into an alcohol concentration that is a little bit below 3.0%. So that's also an option that we can do. We have a relatively high residual extract that's not fermented because the original gravity was once very high or much higher than for beer with 7 or 8% Plato. And that gives a little bit more drinkability, a little bit more body. And when you do this, or when you think about this, please also think about the national regulations regarding labeling that you have in your country. So it differs a little bit, and it's not just by mixing and filling. Also the regulations have to be followed. Now we come to the non-alcoholic beer category, and here we can divide into 3 different kinds or 3 different groups of technologies to produce them. First one that is, meanwhile, it's very, very common as well here in Germany. That's a stopped or short fermentation. And some people do it with cold contact fermentation with the regular yeast, but that's very tricky because then you need to find the right point where you stop the fermentation process exactly by a technology like flash pasteurization to eliminate the fermentability or fermentation power of the yeast. So that's not that common. I think more common is to use this special yeast strain that researchers found some years ago, the Saccharomycodes ludwigii. You can also buy it at, for example, at the Forschungszentrum Weinstefan für Brau- und Lebensmitteltechnologie as a strain number SL17. Also at other yeast banks, you can also get this this yeast as a dry yeast from several suppliers around the globe. So it's very common now, and this has the impact that you only ferment monosaccharides, and then the yeast stops fermentation. So you normally, if you have something like a light beer wort with a gravity between 7 and 8 degrees Plato, then you come out with an alcohol concentration that is still below 0.5% by volume. But what people say and what we know is the more wort-like character, because we have the mainly the unfermented wort that still remains with all its characters, and that has a big impact on the flavor and taste of the final product. So we think that 0.05 or below 0.05% alcohol by volume is not achievable, because you need something to ferment, you produce alcohol. And when we have a look on the other limit, that is 0.5, that's good to achieve, and that makes sense to use this as a goal to stay below 0.5. The calorie content is also something I have to mention, because a lot of unfermentable sugar stays there inside, not transformed into CO2 and into alcohol, and so the calorie content is higher compared to an dealcoholized beer. That is something that we have to know. For some people, it's good because they want calories, they need calories immediately after sports, but for other people, if they drink 2 or 3 liters from this product, the calorie impact is very high. So what we need is bottle pasteurization. We have no other choice like flash pasteurization, because that doesn't work. We need to be 100% safe, not to produce exploding bottles by secondary fermentation after bottling. So the next possibility that we have is DeAlkalization. That is something we do under heat. When I started, we only had one supplier. We produced the beers with a temperature of 42 degrees centigrade. Meanwhile, the process and also the devices are a little bit more developed. So we see some lower temperatures, because the higher the temperature, the higher the impact of the product is. And the dealkalization is a physical game in between temperature, time, and vacuum. The higher the vacuum, the lower the temperature can be to come to the same result of low alcohol concentration in the beer. Problem is that all the flavors are evaporated too. And if you ever have a chance to taste a dealcoholized beer behind the machine, you will be very disappointed, because there's nothing remains than a little bit water, a little bit maltiness, and a little bit bitterness from the hops. That's all. What we can do is aroma recovery with most of this the plants on the market. But if you recover your aroma compounds, they always contain a little bit of higher alcohols, and all in all, you will increase the alcohol level in your final product with this aroma water addition at the end. So 0.05 is possible. I did it. I was always around 0.01, 0.02 when I was running the device there in the brewery years ago. So that's no problem. And we have also loss of all hop aroma compounds due to this evaporation. So everything that we do in advance in the brew house, that is then eliminated later on with the dealkalization. That's how a plant can look like. That's the one in Weihenstephan. And for these beers, we have one option that is also blending with base beer. When you calculate, you have a beer coming from the process of dealkalization with, let me say, 0.01, 0.03%. We have to stay below 0.05. Then normally you can add 8% of the base beer, of the mother beer back, and that brings also a little bit more freshness, a little bit more beer-like taste into your product. Flash pasteurization, you need this flash pasteurization. You don't have that problem with fermentable sugars, so it could be sufficient if you can, if you don't have any residual risks in your bottling or your filling area, because that must be 100% safe. And otherwise, you are going back to bottle pasteurization with all the problems, long time on high temperature, reduced CO2 concentration in the bottle to avoid explosion, and so on and so on. But flash pasteurization could be sufficient. So then the third group, that is the membrane dealcoholization. For this, we have two alternatives. That is dialysis or reverse osmosis. Reverse osmosis is more common. Currently, we see a lot of plants, a lot of devices on the market. They work with the technology of reverse osmosis, where you need pressure to bring the alcohol on the opposite side of the membrane. We don't have data regarding hop aroma compounds by beers produced like this with reverse osmosis. It's hard to get something from the suppliers, and it's hard to get a brewery doing dealcoholization with such a device on beer that has a certain hop aroma concentration inside. So let me see, maybe in future we got more information on this. So achievable is also alcohol concentration below 0.05, and so we also have the same option to blend with base beer back to 0.05, as I mentioned before. And what you need to know is that you always need a lot of water for rediluting, because the process of reverse osmosis also transfers a lot of water from the beer side to the other osmotic side, and beer and water and alcohol passing the membrane, and the other compounds stay on the other side of the membrane, and they are up concentrated during the process, and later on at the end you need water for rediluting with a certain quality of water. So the membrane material, that is a key on all these technologies. To build up a plant like this on the picture is not rocket technology, but the membrane that they use makes the beer quality at the end, and also has an impact on the losses of, for example, hop aroma compounds and also other aroma compounds coming from the fermentation process, for example. Flash pasteurization, what I mentioned before, is the same here. You need to be careful when you only have flash pasteurization. Could be sufficient, but to eliminate all residual risk, you need bottle pasteurization at the end. Now let's have a look on the technologies that we have for taste and quality improvement in general. So that is the brewing process here in this drawing, and the points of hop dosage points in the kettle, that is for bittering, then later on late additions in the kettle or into the whirlpool, more related to transfer hop aroma compounds into the wort. And then we have something special, that is also the hop bag. That's not new. It's a device that, for example, the UK brewers are using for generations now. And that is, let me say, a very late hot aroma extraction before you go through the cooler into the fermentation tank. That's something that's available on the market. Meanwhile, not only for hop cones, also for hop pellets. So what we can do in the brew house regarding stop fermentation, we can create a late hopping aroma in the kettle and in the whirlpool, because we don't lose this hop aroma compounds by evaporation. So we can use oil-rich and linalool-rich varieties, for example, especially linalool-rich, because there we have the late hopping that is more or less correlated with the presence of linalool or certain concentration of linalool in the wort. So we can also use, yes, we also will have a little bit of biotransformation, because we have active yeast cells there. They do not make this big fermentation, and they maybe help to interact, that the cells absorb a little bit of the volatiles like myrcene, and also that the enzymes of the yeast has positive impact on the formation of certain compounds like linalool, like geraniol, and so on, on all the precursors as well. So that's something that we can handle, but on the other hand, we have to know that the yes, that in case of stop fermentation, we have a lot of products we can use, a lot of special products, we can use pellet type 90, we can use pellet type 45. We also have a blend that's called a Trident pellet, where we have a blend of certain US aromatic varieties going into direction of citrusy and fruitiness. And we have concentrated pellets in form of lupulin pellets, where we have the highest possible concentration of pure lupulin that goes sometimes over the 45, and depending on the variety. We can have, or we can use varieties like Solero, like Lotus, and other varieties coming from our own Hopsteiner breeding program here in the US and in Germany as well. So if we have a short contact time with the yeast, we will also find out that let me say that the transformation of aromatic compounds will not be the same because ethanol is missing. And what helps a little bit can be the biotransformation. That is just for your information. We presented it a lot several times ago. And what's going on is very common. And it's also a good point for discussion in between the craft industry, how to bring geranol into the game, how to transform geranol into citronellol, linalol, and terpineol, and how to bring the precursors together with the enzymes from the yeast, because yeast is starting to produce and to release enzymes at the beginning of the fermentation. And then the, let me say, the precursor is split into a sugar or an acetate, and the aroma compound is set free, and then can start the movement here from geranol to the other compounds. And normally you will have at the end of the fermentation process more monoterpene alcohols than in the wort at the beginning, when you have a yeast that is able to do this biotransformation. What we also can do is to transfer as much aroma compounds as possible from the brewing, from the boiling process into the whirlpool. And if we once have a reasonable concentration in the whirlpool, this will be transferred more or less into the fermentation, into storage, and so on and so on. Especially linalol is very stable also in filtration and stays more or less stable at the end in the container. So that means that we have here, for one example, we have 2 points of addition. That is at the beginning of the boil after 5 minutes, and the other one is at the middle of the boil. We have a very high peak of linalol, but linalol disappears very fast because of the evaporation and boiling process. So the idea is to push the second addition to a later point, just before knockout, 5 minutes before knockout. The pellets go into solution. Linalol goes also very easily into solution. It's a good polarity. And then the transfer of linalol is on a very reasonable level into the whirlpool and later on into the beer. So that is one idea that you have to keep in mind. And with a look on the thermal dealcoholization, we know that everything that we made before in the brew house and in the kettle in the whirlpool makes no sense, because everything is evaporated. And it could be the same for membrane dealcoholization, but we don't know exactly. We have to look and go deeper on this. The membrane material is responsible for more or less losses regarding hop aroma compounds. So with a look of all technologies, we have an option, and we have a good option to improve the bitterness and the quality of the bitterness, and also the quality of the beer regarding the antioxidative potential of the beer. When we use incremental hop dosage, that means we have not 1 or 2 additions, we use 3 or 4 additions of hops. We make more portions of the hops, and then we have not only 1 or 2 dosage points, we have 3 or 4 or maybe more. You can also use the first word hopping as the first dosing point. That's not bad. With first word hopping, you always find a very good utilization of the alpha acids. Because we know that the alpha acids, they have a very high antioxidative property, and because they work like an iron catcher, because iron works as a catalyst for the formation of radical components, and by removing iron with the chelate formation together with the alpha acids, we can reduce the iron concentration in the wort during the boiling process. Not only once, we can make it more times, and that leads at the end of a much lower electron spin resonance value. That is the value for the antioxidative property of the wort, or later on of the beer. And that means less radical formation, less aging components, and a higher antioxidative stability of your beer at the end on the shelf. And that's very important, I think. You see, that was once released by Dr. Medner. And here we have a beer produced or wort produced with only one addition at the beginning. Then the ESR level is reduced once, and then it goes up during the other time of fermentation to this maximum level at the end at knockout. And when we have 3 hop dosages, it's one at the beginning, in the middle, and one at the end just before knockout, 10 minutes before knockout, then you see that we have 3 times a reduction of the ESR level, and that ends up in a lower, much lower level of the ESR compared to the other technology. And that is a big difference that has an impact on a better stability, better taste profile, and a better taste stability of the beer on the shelf. That's something that you can read in released papers. I don't want to go deeper in this, but that's something that we have to keep in mind. So now we come to the downstream area, to the cold block, where some people add hops for fermentation, some people add hops to maturation or to the end of the maturation. That is what we call dry hopping. And also here's the point where we can use hop oils for the first time, where it makes sense. Instead of pellets, instead of other hop products, we can go to hop oils, partial or completely, and then we transform the hop aroma compounds from the oil into the beer. That's also something that we can do at the end of the process, before filtration or before the last filtration step that we have. Do not add any downstream products, not only for the hop oils. Do not add any downstream product here behind the last step of filtration, because that can cause problem with homogenization and also with gushing. So what we can do downstream wise regarding stop fermentation, it's always dry hopping that we are now talking about. And as I mentioned before, we have a lot of varieties, and it's better to use some high aroma varieties than some bitter varieties. And what we will see is a little bit lower extraction due to the missing beer alcohol. And what I mentioned here on this slide is that we have to keep an eye on the so-called hop creep effect. That means that I have a secondary fermentation that is induced by still active yeast cells together with released sugars, with maybe also enzymatic released sugars from the non-fermentable sugars from the brewing process, and that leads to alcohol formation, and that is the problem here, and also leads to formation of CO2 gas. But the alcohol formation is the problem, because then you produce alcohol in an alcohol-free beer, and then you maybe have the problem that you do not reach your specification with the maximum alcohol that you want to have in your product. So my recommendation is, when you are using this stop fermentation, also with Saccharomyces ludwigi, he likes monosaccharides very much, you have to keep an eye on the temperature of dry hopping. If you do it on a low temperature like this, at between 0 and 4 degrees centigrade, you will have the effect that the yeast is, let me stay still under temperature shock and do not want to move directly to start with the next fermentation step. And you can stop it at the end when you make your pasteurization step. Is it by flash pasteurization or by bottle pasteurization? That doesn't matter at all. You stop the activity of the yeast cells. When you do flash pasteurization, then there's no more any chance that the hop creep effect can bring up a higher alcohol or CO2 concentration in your beverage. So regarding the dealcoholized beers, if it comes from terminal or membrane dealcoholization, we can also make dry hopping as well. And here it could also make sense if you use some technology like cold contact procedure. That is the one I mentioned at the beginning. It could be also an option to make a stop fermentation. But here, when you make it in a dealcoholized beer, it's not that big problem because you normally have no, let me say, no high amount of fermentable material. Maybe something comes with dry hopping, but you can keep it as well under control when you make it at low temperatures or to 4 degrees centigrade. That means we have the dealcoholized beer together with a hop product, and then we use fresh harvested yeast, not something old, not something from the bottom of a tank where it was for 2 weeks. Must be fresh because fresh yeast has the ability to transfer a little bit of the SO2 and a little bit of fermentation byproducts into the dealcoholized beer, and that gives a little bit more freshness and a little bit more positive impact together with the hop aroma compounds. And we also maybe can find some of the enzyme-driven biotransformation, but I think on a reduced level, because everything works not on fermentation conditions, everything works more or less on these cold conditions as we have under, let me say, under aging, under maturation of the beer. So now we go to our, let me say, more special hop products that we can use. First, in the brew house, we have the option to bring in a reasonable amount of hop aroma compounds. With the late addition, for this we have the pre-isomerized kettle extract, and we also have an aroma extract. And here with another product that is Xanthoflav on DE. DE stands for diatomatic earth. We also have an option to play with hard resins. Not, as I mentioned before, we have an eye on the hop aroma compounds. Here we have an eye on the bitter compounds. So that is something very easy to explain for the comparison of CO2 extract and the pre-isomerized kettle extract, the AIC. For CO2 extract, it takes a while that the extract goes into solution, that it goes from alpha acids into iso-alpha acids. And so let me say at the end of the boiling process, utilization rate is a little bit higher than mentioned here. It's around 35% in average in the brew houses that we know. When you use AIC, you have it immediately because the pre-isomerized alpha acids, they go directly into solution with a very good utilization. And that's the same with the linalool. Linalool goes also into solution very fast because of the polar structure of the molecule. And that is something that you can push from an early dosage point to a very late dosage point, let me say 5 minutes or 10 minutes before knockout. You will see that you have a good utilization of the iso-alpha acids from the AIC, and you will also have a good and reasonable utilization regarding linalool. And so late addition is always a good choice if you have pre-isomerized product using in the brew house. So that has the effect regarding the utilization, the improvement factor. We have a brewery A, B, C, D, where we tested the AIC against CO2 extract. We took 3 of them here. And here we can see that it was always an improvement of utilization of recovery by using AIC compared to CO2 extract in the same brew house. It was not always the same improvement factor because this one here, for example, had also a very nice utilization at CO2 extract, so it was not possible to make it much better with the AIC. So factor is not that high. Then here, for example, it was a little bit better also with the AIC. Everything has an impact. The machines have an impact, the pumps have an impact, and also the time and the point of addition has an impact. on the utilization of the iso-alpha acids and also on the alpha acids, on the iso-alpha acids coming from CO2 extract. So if you go from CO2 to IC, the only thing that is changing that you transfer the alpha acid into iso-alpha acids, the beta acid concentration and the hop oil concentration stays the same. And with an eye on the positive advantages of isomerized cattle extract, it's made from Hopsteiner CO2 extract here in our facility in Mainburg. We have cost savings because of the better utilization, but it depends on the market situation of alpha. And between the utilization of bitter substances, we can shift a very high utilization of aroma substances by a late addition into the kettle. Please make it in the kettle, not in the whirlpool. Then you have problems for regarding homogenization of the IC. So it's something that we can use for non-alcoholic beers, but only for stop fermented products. And then we come to aroma extract. So that is the, let me say, the IC without the iso-alpha acids and with a reduced concentration of beta acids. That's something we can see here. So alpha and iso-alpha is on a relatively low concentration. The beta is reduced dramatically, and by reducing all these bitter compounds, we increase the concentration of the hop oils, can be in between 15 and 45%. You see that is a big potential for aromatization when you use this aroma extract late in the process. I mentioned late in the process, dosage point should also be, let me say, before knockout, not in the whirlpool. Okay, that's all I mentioned. And now let's have a look on the third special product that we can use in the brew house to improve the quality of non-alcoholic beers or light beers. That is what we call xanthoflav. That is the xanthoflav family, and that is one product out of this family that is on diatomatic earth. We use the DE as a carrier. So that means that we bring this, let me say, hard resin fraction containing xanthomol, also containing other bitter compounds, bring it on the carrier, and that leads to a total resin concentration in between 15 and 20%, and all the other compounds, 85 to 80% in this case, they are diatomatic earth at the carrier. So it's a powder, it's still a powder, and it's flowable as a powder, it's not hard. If you make the calculation, the back calculation here, when you put together all these compounds, you still have a gap of 10% of resins to come to the 20%, and these 10% of resins are other hard resins. With the positive impact coming from the hard resins, I think there was also a presentation regarding this from my colleague Martin Bindel, and this is something that we can transfer by using this product in the brewery. What happens also, what we have to know is when we do it in the brew house under hot conditions, and that is the point where you have to dose it, we transfer a lot of xanthomol into isoxanthomol. It is the same, let me say, same isomerization process compared to the isomerization of the alpha acids. But here at the end in the beer, you will see that the concentration of xanthomol will be relatively low, but you have a lot of isoxanthomol and you have a lot of hard resins, and they have a relatively good impact on flavor and bitterness taste and on taste stability. So we use for this the ethanol extract, where we eliminate the hard resin fraction out of this, and we can increase the factor of hard resins and xantho and isoxanthomol up to factor by 8 to 10%. And what I also found out when I once produced the xanthomol rich or enriched wheat beer in the brewery, that was a very good shelf life of the product. We tasted the beer after 3 years, after bottling, after producing, and it was still fresh. We were very excited about this, and in these days, it's 15 years ago, 16 years ago, we had no idea what was the reason for this. We said, okay, there must be xanthiumol or isoxanthiumol, but when we had a calculation later, we saw that we also were able to transfer a lot of hard resins into the beer. And these hard resins, a lot of them, much of them have a, let me say, a structure like a polyphenol. And so this is a very high antioxidative or potential that you bring into the beer. And that is also something that we maybe need when we produce non-alcoholic beers, because during all these processes that we have, all this impact of heat, of non-usual production in the brewery, maybe also because it's a small batch compared to the big brands that we produce, we have to keep an eye on the shelf. What happens with the beer on the shelf? What is the aging that the beer shows there? And can we do something against the aging and against the oxidation? And that's, I think it's a good idea to talk about. So now let's go to the downstream area, and that is, let me say, it's more or less related to the usage and application of hop oils. With an eye on the hop oils, we have, let me say, two different families. That is a generic family, and that is a variety-specific family, where we use a pure variety-specific oil after distillation process. And here we produce fractions, and then we, let me say, we standardize fractions regarding the application the product or the hop oil is used for later on in the brewery. So that we can do it in stub-fermented beers very easily. We can also mask this wort-like flavor by hop aroma compounds coming from hop oils. It's possible to create a late hopping-like character or a dry hopping-like character. That depends on the hop oil I use there downstream. And we can use these hop oils, as I mentioned before, in each step of production behind the brew house. Everything that's cold is fermentation, maturation, or at filtration. Maybe we have some reduced biotransformation. We don't know exactly. It could be something that happens. We have no precursors there because it's just pure oil. It doesn't contain any sugars. But if the yeast has, let me say, a little bit enzymatical power, then we also have a little bit impact from biotransformation on these hop aroma compounds coming from a hop oil addition. But that still needs to be determined in the future. Going now to dealcoholized beer, where we can also use the same categories of hop oils as I mentioned before, with the same attributes, with the same approach at the end for late hopping or for dry hopping. And what I mentioned always here is also a cold contact procedure, because that helps. I tested it. This time we do not use a hop product like pellets. Here we use the hop oils together with the dealcoholized beer and the fresh harvested yeast. And we also are able to maybe to bring some of these taste and flavor positive compounds. And also SO2 is also positive against radical formation into this dealcoholized beers. We think that we don't have the problem with the hop creep effect because we don't have an impact from fermentable sugars or from any enzymatic from the hops by adding hop oils. So that is how they look. For the late hopping-like character, to create late hopping-like character, we created our type Noble, Noble Plus. And here we can see that is a constant level of 10% linalool for the Noble and a constant level of 20% linalool for the Noble Plus. So on these levels, we standardize our Noble family. And that means with a high concentration of linalool, we also reduce the concentration of the of the unpolar fraction like myrcene, humulene, and caryophyllene. All these terpenes are reduced, and the terpene alcohols, and we think and we know that it's not just linalool. We also find the other compounds of this group of the terpene alcohols like geraniol, terpineol, and citronellol, as well. Some esters will be present there, and these compounds, they present this late hopping-like character, and that is something I can achieve by late addition before the last step of filtration easily. We have these products on the market because we know that the different crops that we have around the years are not stable. Here we have a slide that shows the ratio of linalool to alpha, because it's very important to know for those brewers who want to create late hopping-like character on their beers in the whirlpool, for example. And the variety stuff here is something that presents a lot of differences. It goes up and down in between the crop years, and you always have to calculate new when you come to pellets from the next crop. And that is something you have to know. By using hop oils, you don't have the problem because everything is calculated to pure oil. Here's some other varieties from the Hallertau is Perle, Tradition, Mittelfrüh, and also a bit of variety Taurus has a reasonable linalool concentration, but on the other hand, a very high alpha concentration as well. Let me say they all behave the same, but not Perle, but Perle itself is on a very low level of linalool and has not really impact on the creation of a late hopping-like character in the beer. Here we have the dry family. We have a product that is a generic one. So that is, these are the remaining fractions from the other processing. We have only traces of linalool, and we have reasonable concentrations of mono and sesquiterpenes inside. And the dry variety specific depends on the variety specific situation regarding these certain components in a crop year. That can also differ a little bit from crop to crop, that you have a little bit less myrcene and a little bit more linalool. Differs by the crop year. That's something also that we have to know and that we bring together with a certificate of analysis when we sell these products to our customers. So the advantages of the hop oil: we can create dry hop or late hop character. We have a masking effect against saline compounds, especially for Noble Plus, because they are related to linalool. And we have no annual variations. We have no plant material. We have no green material. We have no nitrate entry. It's free of nitrate. It's also free of bitter compounds, and it's light stable at the end. So coming now to the end of my presentation, it's time to stop now. So we learned a little bit about how we can handle hop aroma compounds, hop bitter compounds in low and non-alcoholic beers to make this product a little bit more drinkable. I think for myself, it's regarding the low alcoholic beers, it's not a big gap. It's all handleable. But regarding non-alcoholic beers, yes, hop products have a good solution if they are used in the different alcohol-reduced beers to create a little bit more drinkability, to create a little bit more hoppy flavor and hoppy aroma. And we have seen that a lot of non-alcoholic beers, even around our area here in Bavaria, are popping up from small breweries. They are now able to make the stop fermentation with the Ludwigi yeast strain, and they are able also to make dry hopping, for example, and they produce very nice products. So keep it in mind. And I want to end now, give the word back to my colleague, to Sandro, and then we can start with our discussion.
Thank you, Frank. Perfect. Very intense presentation, and you showed plenty of possibilities. Summing up, it looks like, especially for the alcohol-free beers, especially with the hop aroma is more the issue to focus on, as you can make a little bit more out of an alcohol-free or alcohol-reduced beer rather than improving a lot on the bitter side. Is this correct?
Yes, this is correct. When we go back to the slides, I only was showing one option to improve the bitter side a little bit. That was with the addition of a xanthiumol product in the brew house.
Yeah. And the incremental hop dosage that you mentioned in the beginning, I'm sure this is an option because this is also one of the questions about the storage stability of alcohol-free beers. That is often an issue. So probably the incremental hop dosage is one part to improve the stability, but also on the other hand, as you mentioned in the end, the usage of hop oils or aroma-rich products to have a certain level of bitter flavor, of a hop aroma flavor in the beer to mask not only the wort character but also this aging components that are formed over the time. So, what is your experience with the storage stability of those beers compared to the regular beers?
So what I have seen is that the storage stability of a dealcoholized beer is a little bit better than the storage stability of a stop fermented fermentation produced alcohol-free beer. That is what I can say in average. That is what I feel, what I can taste and smell when I have these beers. To be honest, I don't drink not that much alcohol-free beer, but I produced it or I produced them for a lot of years. And when you have a look on the options that we have now, you can combine them. It doesn't matter if it's Reinheitsgebot or not Reinheitsgebot. You have a lot of options, and to combine them, to bring them together with an eye on the product itself, because to bring hop aroma compounds into a Pilsner style beer or bring it into an ale or an IPA alcohol-free, that's a big difference. It depends on what you want to achieve at the end.
Yeah, but picking up the aroma again, as you just mentioned, I guess also the cold contact procedure that you have shown in your presentation is for sure something to improve the taste not only of the fresh beer but also over time. Do you agree?
Yes, absolutely. Because you have a lack or gap of concentration in between the yeast cell itself and the beer that is dealcoholized, and there's a gradient of compounds. And I think that because of this gradient, some compounds from the yeast cell is osmotic, they move into the liquid. It's not that much. We cannot say that is a technology that brings everything back to a normal beer taste and flavor, but that is something that you can also taste later on. But you need fresh yeast, you need a little bit time, you need very cold temperatures, and then you can handle it without any secondary fermentation or something that's dangerous. But also we have to talk about microbiology. That's could be also a part of a presentation, but not from my side, but have an eye on the microbiological situation in the brewery.
Okay, very good. Another question that was coming in is about the hop creep effect, and if you can exclude it completely by using products like aroma extract or especially hop oils on the downstream side, I guess we can definitively confirm this. Frank, I'm sure you agree that there's no enzymatic reaction coming from the hops, and especially for the alcohol-free beers, each tenth of alcohol that is formed might be the issue on labeling again. So probably for those kind of beers, especially the downstream products like the hop oils, are of main interest.
Yes, absolutely, and that's also one comment from my side, from my time as a brewmaster. Be careful with the alcohol concentration before you release the beer from the brewery. Please check the alcohol concentration. If you send something out that is in Germany that is not 0.49, that is 0.50 or 0.51, then you have problems. If they catch you, if they make the analytics there in their analytics in their laboratory, then it causes very much problem. You pay a lot of money, you have to put the beer back from the shelf, and that's a big issue.
Okay, a final question that we might pick up shortly before we close the session that just popped in now is about the biotransformation, and is it still ongoing at 0 to 4 degrees? I guess it's referring to the geraniol biotransformation, not to the hop creep effect. So maybe you'd like to comment on this?
Yes, the lower the temperature, the lower the enzyme is going on and is working. That's right, absolutely. And that's something you maybe found out by yourself when you make dry hop beers and you have the dry hop addition into the, let me say, into the young beer where the yeast is present, and you make it as an ale under higher temperature. You have a better result. You have a better impact of biotransformation compared when you make it at lower temperatures. That's absolutely right.
Yeah. So I can also agree to that. I mean, we always see the beers that are dry hop, let's say, in the mid of the fermentation are much more fruity in the end compared to those beers that have only that are only dry hopped during maturation or end of maturation. So for sure, this reaction is time and especially temperature dependent. And in this case, it's definitively better to force it at higher temperatures.
Yes, and we have to know that the beta glucosidase that is responsible for the enzymatic effect of biotransformation has an optimum temperature that is around 60 degrees centigrade. So that's, yeah, that fits into the other temperatures that we know from the brew house from mashing, but in your fermenter you are far away from this high temperature. But the lower you go, the less intensive the ability of the enzyme is to produce a free aroma compound like geraniol and to split it up from the precursor like a sugar molecule, for example.
Okay, thank you very much, Frank. I would say it's time to close the session now. We have covered all the questions as well. As you mentioned, we're still searching for somebody who's using a membrane technique to to have a deeper insight in that. So maybe somebody is hearing us and would like to have a closer look to their beers, and then we would be happy to support more trials. But of course, everybody is invited to share your insights of the production of alcohol-free or low-alcohol beers, and to optimize existing hopping recipes with us together if needed. So we would be happy if you contact us with regard to this topic, as we have also a lot more experience than we can cover in 1 hour. Okay, yes. So then it's What's your final word, Frank?
my final word, yes, I have to say the same. We have in the 21 R&D project list, we have this on a very high position, the non-alcoholic beer topic, and we are happy with every contact that we get from the industry.
Perfect. Okay.
Thank you very much.
So thank you very much. It's time to close the session now. You will shortly receive an email with a link to rewatch this video from today's recording, and you will also get the question if you give us a very short feedback, which we very much appreciate. The next webinar will be held by Dr. Martin Bienel on Thursday, the 8th of April at the same time. We hope to see you again when Martin will give a deeper insight in our total resin extract, an ethanolic hop extract that is very close to the original composition of hops. So that's it for today. All the best, stay healthy, and hope to see you soon again. Bye-bye.
Bye-bye.